Okay, welcome to our last video for this series. So this is still the chapter on supply management, and this is not in the Excel extra credit, but we're going to do it in Excel anyway. It's a practice problem for the exam, and it's basically the impact of quality on our purchased material cost. And what we need to do is fish out of this problem the relevant information. I've already built a little table down here that would help you, but you need to be able to do this in an exam. So let's talk about it. Dusty is evaluating 3 bids to supply fence hardware for the 5 acres of pasture that need to be fenced. Breezy submits a bid of $40 per unit with a defect rate of 3%. Lady's bid is $50 per unit with a defect rate of 0.5%. And Spike's bid is $30 per unit with a whopping defect rate of 5%. If a section of fence fails, it costs an average of $500 in losses and herding costs to round up all the capybaras. Dusty believes it will take 1,000 units to fence in this pasture configuration. What option has the lowest total cost? So I built a table here, and it's important that you think, don't just watch the numbers drop in, but think about what we're doing here so that you could do it in an exam. So we're going to try to figure out what the total cost of the fence is, regardless of quality, and then we're going to calculate the cost of poor quality to give us that additional cost to find the total cost, right? So the bids per unit will go in first, the way that I designed this. So that's $40 from Breezy and $50 from Lady, and Spike gave us a low bid of $30. The total units is the same for all 3. That's 1,000, which is what old Dusty has estimated. The cost of the 1,000 units would simply be equal to the cost for one section times the 1,000 sections, right? And we can copy that across because all these cells have the same relation. If this is right and we drag it over here, these will be right and these will be right. So we got $40,000, $50,000, and $30,000 for the raw fence. Now, we have a defect rate, and let's go see what those are. So Breezy has a 0.03, 3%, and Lady had a 0.005, 0.5%, and Spiky Boy had 0.05, 5%. The cost per defect is $500 for any of the, regardless of who provided it. And the number of defects is going to be the total fence units times the defect rate, right? So equals the 1,000 units times the defect rate. Then we can drag that across. Boom. So 1,000 times 3 is 30. 1,000 times 0.5 is 5. And 1,000 times the 5% is 50 bad sections. The cost of defects would be equal to the number of defects times the cost per defect, right? So $15,000 for Breezy Boy and $2,500 for Lady's quality, which was very good quality. And old poor Spike's got that 5% problem, so he's got a $25,000 cost of quality. You can see where this is going. We've got a cost of material and we've got a cost of defects here. And we're going to sum them up and get the total. So the total equals the cost of the materials plus the cost of the defects. And why'd you jump down there on me? Okay, that equals $55,000. We can copy that across, and we see 55, 55, and 5250. Right. So the answer to the question would be the option with the lowest total cost is Lady. So the highest cost per section is the lowest total cost because the quality was excellent. We see it here. Lady's got the quality. and that's what won her this position of the lowest total cost. I hope that that helps put in perspective that we use lots of different costs when we source. This is just one example of how to build out total cost. And that ends the video.